Hi there, it's Mrs. Tellas. Today we're going to be doing more power stuff, more exponent stuff in section 6.1. We're going to divide powers with the same base, and we're going to raise a power to a power. So we're going to do two different skills here. It's kind of separated in the notes. So here we go. All right, dividing monomials. So here are the directions. To divide powers that have the same base, you subtract the exponent. So when we were multiplying powers that had the same base, we were adding the exponents. Now we're going to subtract. And I usually go either to the numerator, the denominator, wherever there is more of that particular variable or number, I usually go there. So on this one, I've got a to the 17 over a to the 13. So I'm subtracting the a. Let's move that. I'm subtracting the a's, so I'm going to go up to the top because there's more up on the top in the numerator. So a to the 17 minus 13 is a to the fourth. And that's a simplify problem because it's a variable. I can't go any further. So if I look here, I've got to divide x's and I also have to divide y's. And again, I do them kind of separately in my brain and then I put the answers together. So for the top one, for the x, I'm going up top because there's 6 up here and there's only 1 here. So x to the 6 minus 1. And for the y's, I'm also going to the numerator. So y to the 3 minus 2. So my answer is x to the 5th, y to the 1st. All right, so same thing here. I've got some y's and some z's that I need to take care of. And looks like there's more up top for both of them. So y to the 8 minus 6 and z to the 10 minus 4. So this is y to the 2nd, z to the 6th as my answer. Okay, I hope you're getting the hang of it there. So we're really just looking for same bases, either going to the numerator or denominator, wherever there's more of them, and subtracting the exponents. Okay, let's try this one. So now I've introduced negatives in here, but it's really not any different. Now there is a trick with negatives. If you switch them, which I think I'll make everything positive first and then arrange if I need to. So this is from earlier in chapter 6. So there are no other x's, but it's got a negative exponents, which means it's unhappy. It needs to be moved to the opposite part of the fraction. So x to the 6th is going to come down to the bottom, and then I look at the y's. It's the only one, but it's unhappy. So I'm going to move it to the top. So y to the 4th, and then z to the 9th. Again, it's the only z, so I just leave it where it's at because it's happy where it is. None of the bases are the same, so that's as far as I can go. So I like to make all of the exponents happy first, and then at that point, either multiply or divide, depending on where everything lands. So on this one, 75 divide 15, well, we can take a 15 out of both or divide, and that leaves me with 5. So 5's in the numerator. My p's are in good shape. So p to the 3rd and p to the 5th. So I'm going to deal with those. So since there's 5 p's on the bottom, I'm going to do p to the 5 minus 3. These are all unhappy, so I'm going to move them all. So q to the 5th is going to go down. Q to the 5th is going to go down to the bottom, and q to the 4th is going to go to the top, and r to the 8th is going to go to the top. So those are all happy. Okay, so now I can go ahead and deal with my q's because there's 2 of them. There's more on the bottom, so I'm going to go to the bottom. So I've got a 5r to the 8th on top, and then p to the 2nd because 5 minus 3 is 2, and then q to the 5 minus 4. So my final answer is 5r to the 8, p squared, q to the 1st. And I don't need to put the 1st. I can, but I don't need to. All right, let's look at number 6. So negative 4 has nothing to cancel with, so it stays in the numerator. There are more x's on the bottom, so x to the 5 minus 3, so negative 4 over x to the 2nd. Okay, and then here we've got some things to deal with. We got some A's, we've got some B's. Okay, but I also have unhappy ones. So I'm going to rearrange my unhappies and make those happy first. So that's going to the top, that one's going to the bottom, that one's going to the bottom. And the 2 and the 3, can't do anything with 2 over 3, so I'm just going to list those. So a squared is going down to the bottom, b is staying. C to the 1st is going down to the bottom. Okay, in the denominator, the a stays and the b squared goes up top and making it positive. So now I've got actually some multiply. This is really more of a multiply problem, even though it's a big fraction. So b to the first times b to the second, I would add these, b to the 1 plus 2. So that's 2b to the third. And then here I'm going to combine those two. There's a 1 there, so a to the 2 plus 1 would be 3a to the third. And then I have the c there. So this is my answer. All right, number 8, finding the power of a quotient. You find the power of the numerator and the power of the denominator. So these each have an exponent of 1. So 4 times 1 is a to the fourth, and 1 times 4 is b to the fourth. So that is my answer. Here, each of these get multiplied by a power of 3. Each of the exponents multiplies. So 3 to the 1 times 3, p to the 2 times 3, and 4 to the 1 times 3. So that's 3 to the third, p to the sixth, and 4 to the third. Let's see, 3 to the third is 27, and 4 to the third is 64. And I don't believe that simplifies. I think that's the answer. Here I do the same exact thing. So 2 to the 1 times 2, x to the 2 times 3, 3 to the 1 times 2, and y to the 4 times 2. So that's 2 to the second, x to the sixth, over 3 to the second, y to the eighth. So that's 4, x to the sixth, 9, y to the eighth as my answer. Okay, so on this one, I really do the same thing. So it's got an extra step in it because it's negative. So I could, actually, I'm just going to go ahead and multiply them all. So 2 to the negative 2, x to the negative 12, and y to the negative 8. Well, every single one of those is unhappy and needs moved to the opposite part of the fraction. So y to the 8th is going to the top, 2 to the 2 is going to the bottom, and x to the 12. So I just switched their positions and made their negative exponent positive, and then I just need to evaluate 2 to the 2. So that's 4x to the 12, and that one's my answer. Hey, this one looks horrible. It's really not that bad, though. There's a lot going on. Let's put my ones in here so I don't forget any of them. All right, so where there's no exponent, I put a 1. So this is 2 to the negative 3, a to the sixth, b to the negative 3, c to the third. Now the bottom, the denominator. 3 to the negative 3, a to the negative 3, b to the sixth. So I've got some unhappies here. This one is, this one is, this one is, this one is. So I'm going to move everything around, make everything happy first. So 3 to the third's coming up top, a to the third's coming up top, a to the sixth stayed, c to the third stayed. Okay, so I took care of that one, that one, that one, and that one. Okay, so on the bottom, I'm putting 2 to the third, b to the third, and b to the sixth stay. So I think I got them all. All right, so now I got to gather them up and come up with the number. So 3 to the third is 27, and 2 to the third is 8. And then these two a's can be combined because it's a multiply problem. So I add those exponents, that's a to the 9. And these two b's can be combined because it's a multiply problem. So that's b to the 9. So that's my answer. All right, so that's dividing. Now let's do, I'm raising a power to a power. So when we raise a power to a power, we multiply the exponents. So this is a to the mn. So here this is 5 to the 8th. I don't know what 5 to the 8th is. Let's look. Does it say simplify or evaluate? Because if it said simplify, it didn't really have a direction. Let's just put it in. So 5 to the 8th power is 390,625. So this would be m to the 15 because I'm just multiplying 3 times 5. That's all I'm doing. Notice that the base is staying the same each time I multiply. So just multiplying my bases, that would be x to the 20. This would be n to the 28. This would be p to the negative 20, except, oh, can't have a negative exponent. So we make it happy by moving it to the denominator instead of the numerator. So 1 over p to the 20 is the answer. Okay, so here you've got power to a power here, and then you've got multiply in the front. So when I do my power to a power, I just pull the front one over because I'm going to multiply it by whatever this answer is. So y to the negative 10. And since this one's unhappy, I'm going to go ahead and move it down to the bottom. And then I've got a little division problem. So we're going down to the bottom. So 1 over y to the 10 minus 3 is 1 over y to the 7. Okay, so if we do that same thing, this would be power to a power right here. So that front one just gets copied because it's a multiply. That's x to the negative 24. So that one's unhappy. He's going to the denominator, to the opposite part of the fraction, to make it a happy exponent. And then it's a little division problem. So 1 over x to the 24 minus 2 is 1 over x to the 22. Press pause and try 9 and 10 and see if you can come up with it, please. All right, so y to the negative, or w to the negative 2 and w to the 21. Well, this one's unhappy, so he's going to the denominator. And then I'm going to go up top because there's more up there. So this is w to the 21 minus 2. My final answer is w to the 19. Did you get that right? Good. All right, here I'm going to multiply, or I'm going to power to a power these two. So that's r to the 10 and r to the third, and those are multiplied, so I add exponents. My final answer there is r to the 13. Okay, so this is power to a power, so I'm raising both of these to the third power, so I'm going to multiply by 1 on each. So 4 to the third, m to the third, and let's see, 4 to the third is 64, I think. Let me make sure. Yeah, it is. That's my answer. All right, keeping to move through. When we raise a product to a power, we multiply the outside power by each exponent. The base stays the same. So we just did one of those. So these are both ones. So this would be 3 to the 1 times 4 and x to the 1 times 4. So 3 to the 4th, x to the 4th, and 3 to the 4th, I think is 81. Let's look. Yep, 81 x to the 4th is my final answer there. You try number 3. It's the same thing. And number 4. So press pause and give those a try, please. So this would be 5 to the 1 times 3 and x to the 2 times 3. So 5 to the third, x to the 6th is 125 x to the 6. Same thing here. So 7 to the 1 times 3 and m to the 8 times 3. So that's 7 to the third, m to the 24. So 7 to the third power, 343. I only have those memorized during this chapter, and this is the beginning, so we'll get going there. Hopefully you'll memorize some of them too. Okay, so this one, these are both ones, so I'm going to do 2 to the 1 times negative 4 and z to the 1 times negative 4. So that's 2 to the negative 4 and z to the negative 4. These are both unhappy, so they have to go to the denominator. So 1 over 2 to the 4th and z to the 4th. So 1 over 16 z to the 4th is my answer. 2 to the 4th, I believe, is 16. Yeah, it is. Okay, so first I multiplied the exponents, then I made them happy by moving them to the denominator, and then I evaluated them. Okay, why don't you press pause and try 6, 7, and 8, and then I'll come behind and do them too, and you can check and see if you're right. So there's an exponent of 1 here, so this is 3 to the 1 times negative 2, g to the 4 times negative 2. So 3 to the negative 2, g to the negative 8, both unhappy. They go to the bottom. And my final answer is 1 over 9, g to the 8th. If you got that right, give yourself a pat on the back. Good job. All right, same thing here. So 5 to the 1 times negative 3 and a to the negative 4 times negative 3. So 5 to the negative 3, a to the 12. This one's unhappy, so he's going to the bottom. A to the 12 over 125 is my answer. Number 8. So I'm just multiplying the exponents, x to the negative 3 times negative 4 and y to the 6 times negative 4. So that's x to the 12, y to the negative 24. This one's unhappy. He's going to the denominator. So x to the 12th over y to the 24th is my answer. I hope you're catching on. Okay, they're getting longer, but they're the same thing. So this one's power to a power, and this one's product to a power, but we're multiplying exponents here. So here we go, at least in the first step. So n to the 5 times 2 would be n to the 10. These have exponents of 1, so I'm going to multiply each of them by 3. So 4 to the 3, m to the 3, n to the negative 6. All right, then I've got an unhappy one right here. So I'm going to move that one to the denominator. So 4 to the third is 64, m to the third, n to the 10. I like them in ABC order also. And then these two have the same base, so they can be divided. And I go up top to do that because there's more up there. So that's 10 minus 6. So 64, m to the third, n to the fourth is my answer there. You try 10 and 11 and see if you can get those right. Give it a press pause and try them, and then I'll go through and work them out too. All right, so on this one, I'm just multiplying powers, power to a power. So x to the negative 4, these each have an exponent of 1. So 3 to the 4 times 1, x to the 4 times 1, and y to the 20, 5 times 4. Okay, I've got an unhappy one right here. I'm moving him to the bottom. So 3 to the 4th we decided was 81. Those all stay, and that one goes to the bottom. And now 4 and 4, those are exactly the same thing. So when I cancel them, it equals 1. So they're just gone. You could also do 4 minus 4, which is x to the 0, which is 1 as well. So my final answer here is 81 y to the 20. Okay, and then if you've done the last one, hopefully you did. You've got some 1 exponents here. We need to make sure we know that are there. So 6 to the 1 times 3, a to the 1 times 3, and b to the third. And this is 5 to the 1 times 2, and a to the negative 6. So we have one unhappy here that I'm going to move to the bottom. So 6 to the third, let's see, 216, a to the third, b to the third, times 25, and then a to the 6 is going down to the bottom. So we need to know what 216 times 25 is, because I don't know. Let's see. It's 5,400, and it's in the numerator. And then a to the third, b to the third over a to the 6. Well, these two can be divided because you've got an a on the top and an a on the bottom. There's more on the bottom, so I'm going to do my subtraction of exponents down on the bottom. So 5,400, b to the third over a to the third. That's my answer. That was a hard one. Okay, so you're going to big ideas now and working on the 6.1. There should be work. I mean, you saw how much I wrote down for each one. Okay, they don't just magically come to you. Maybe the easier ones, like at the very beginning, like these, maybe you can just write down the answer. But anything that's bigger than one step needs to have work written down. So there should be a logical order to your paper. It should be numbered, and I should be able to tell what's going on that paper. So please submit that work on Canvas, and please check for correctness on big ideas. Thanks very much. Have a good day.